This is the third section of chapter 13 on integration, and this section is about finding functions. Now, the questions that we've done before, we've always put plus c on the end. Now, it is possible to calculate the value of the constant of integration c if we know a point that the graph or the function passes through. So typically, the type of question we might get is that we're given the gradient function of a curve, the derivative, the first derivative. We integrate that gradient function to find the function itself plus c. Then we substitute in a point on this curve f of x, which will normally be given in the question, and we can substitute that in then to calculate what the value of c is. Example 6. The curve c with equation y equals f of x passes through the point 4, 5. Given that f dash of x equals x squared minus 2 over square root of x, find the equation of c. So let's write down f dash of x. So x squared minus 2. Now I'm going to write the square root of x as x to the power half. Then I can split this up as x squared over x to the power half minus 2 over x to the power a half. Still not written in the form that I want. So here I'll just subtract the powers. So that'll give me x to the power 3 over 2 minus 2 times x to the power negative a half. So that's what I'm going to integrate. So integrating f dash of x with respect to x is going to be integrating x to the power 3 over 2 minus 2 x to the power negative a half with respect to x dx. So let's do that. So we've got x to the power 3 over 2, so we add 1 to that, becomes 5 over 2 divided by the new power 5 over 2, we'll tidy it up in a minute, minus 2x to the power a half, we add 1 to the power, we divide by a half, and then we plus c. Right, so let's tidy this up. So dividing by 5 over 2 is the same as multiplying by 2/5. So you've got 2/5 x to the power 5 over 2, and dividing by a half is the same as multiplying by 2, so you end up with negative 4x to the power half plus c. Now we're given this coordinate here 4, 5. So we know that when x is 4, we get 5. So this is f of x. F of x, or y, is equal to this. What we've got here is 2/5 x 5 over 2 minus 4x to the half plus c. So now let's sub in 4, 5. See what happens. We should be able to work out c. So 5 is what f of x is going to be, or like y. So 5 equals 2/5. And then x, which I was going to write down, x is now 4 times by 4 to the power 5 over 2 minus 4 times by 4 to the half plus c. So we'll just rearrange this to find c. So c is going to equal 5 minus this 2/5 times by 4 to the power 5 over 2 plus 4 times 4 to the power half. So we can work that out on our calculator, and I've done that already, and I will get c equal to 1/5. So now we've found the last bit of the puzzle that tells us what the equation of c is. So it's this plus c, and c is 1/5. So we'll write down the equation of the curve c is, and we can write it as either f of x equals or y equals. Now since it says the equation y equals, we'll write y equals. So y equals, so we're just going to write down this bit here and change the plus c to 1/5. So we've got 2/5 x to the power 5 over 2 minus 4x to the power half plus c, and c is 1/5. So that completes this question. that is the equation of this curve. So we're able to work out that constant of integration because we were given a point that the curve passes through. So you should now be able to finish exercise 13C on pages 294 to 295 of the textbook.